infrastructure components. The EC2 having a role which has the ability to access certain other AWS services in your account. We have talked about that as well. So when we are looking at, security in the cloud, even if your application is in a private subnet, even if no one can reach those instances, we should still follow some of these best practices and try and externalize all of these and make sure that these values come from a central repository. Speaking of a central repository, you also do have the ability to to deploy your applications in a very controlled manner. And there are services the cloud provider offers which can keep track of your AC, or rather the infrastructure state. If it changes, you can get notifications. Right now, what kind of changes are we talking about? So you can say that I have a bunch of environment variables. Their values are whatever. That particular instance carries this kind of data, and this is what it looks like. So you could have a service which ensures that any change from this state be notified to a central administrative user, perhaps even the security cell. So if someone tries to get in and modify some of these values, right, the notification is immediate. And the central security cell wakes up and says, oh, wait a minute, right, somebody's trying to modify these instances without proper authorization, perhaps. The other aspect that we need to keep in mind is when we are looking at, from a security perspective, is what kind of checks and balances we have in place to ensure that even if somebody did get access to my application infrastructure, I be notified. We've talked about CloudTrail. So you could have a way by which you can say that I want to particularly keep an eye on all the logins that are happening after business hours. So you could potentially write, let's say, a Lambda that can trigger a monitoring service or a custom code or whatever it might be, which piggybacks on CloudTrail's ability to keep track of all the logins and any and all infrastructure changes done, right, and can continue to report that in real time. Like, honestly, I have implemented the same. About 2.5 years back, April 2018, I don't know if I've shared this story with you guys or not, right, I got 6.5 lakh bill. 6.5 lakh translated to USD is $10,000 in 12 hours. So there was a hack in my system, and the total bill in my account was 10,000 USD. That's a lot of money. Now the question is, how do you do tracking of this? How are you made aware that such a thing is happening? So from a security perspective, there are two approaches: proactive and reactive. So if you set up a billing alert, that's reactive. The damage is done, but at least you are aware of it. Proactive would be, can I find out that, hey, somebody just logged in based on CloudTrail? Can I get an email? Can I get a notification on my mobile phone? Right, on my cell phone, saying that, hey, listen, this user has just logged in, and I can immediately get in and find out what's going on. I've set that up. So anyone getting into my account, right, of course, I have a couple of family members like my nephew and daughter and all these guys, they're using my system, so I get notification every once in a while when they get in, right, and I look at that notification and I look at the name, oh, okay, yep, that's my nephew who just got in. Like, good, no worries. So these kind of real, security measures. So security is not always about, your applications. Obviously, it is that. It's also about securing your, or rather having these kind of notifications in place that helps reduce the damage. By the way, in case you are wondering what happened to that $10,000 bill, so it was a month-old cycle that I had to go back and forth with AWS, and AWS did their own analysis, and they concluded that yes, indeed, based on your historical use of AWS for over 5 years, we clearly see that this is not the standard usage pattern, so somebody gained access. No worries, we'll take care of it. So they gave me a whole bunch of best practices to follow, and all of that I've shared with you now. CloudTrail, notification, multi-factor authentication, root user don't use, which I was not using anyways, right? Public subnet, private subnet, all of these things that I've been talking about, right? And which is very well published in open forum as well. All of that was shared. So I've gone through that cycle, and good thing is they gave me credit. You want to know how much? Well, the actual usage, if the breach did not happen, was around $550 USD. So they gave me credit of $9,500. How good is AWS? So yeah, I mean, the cloud provider can be generous, can be, compassionate with respect to your perspectives, etc. But you know what? I'm not going to get this lucky every time. Right? If I have another breach, AWS will try and say that, looks like last time I gave you the credit, but you didn't really learn from that exercise now, didn't you? This time, you got to take the hit. And maybe this time you'll understand how not to do things. So it was a one time, so I did get the credit of $9,500. Really awesome. Anyway, so that's about security. It's not just about your application authentication authorization, but also having all the checks and balances in place using the tools that we already talked about, right? Please do keep in mind the best practice of private subnet. Try to have everything in private subnet, right? Try to have only the components which will interact with the outside world in the public subnet, and nothing else. If I were to put all of these things together, I know the picture may not be very clear, but that's okay, right? So you have all of these entry points where users can come from. They get in through API gateway. And I know API gateway is something that we have not done, but it's so entry points where users can function. You can take they get in through API gateway. And I know API HTTP backend, and you can really tie it with the API gateway rather quickly. All you have to do is just create an API gateway name, and then you can set a route, and you can from a drop down pick what your backend is. Let's say Lambda. Just provide the Lambda function, click OK, done. So the DNS of the API gateway / the route that you put, right? For example, ordered service, right? That's it. The moment you hit that, your Lambda function will be called. Seriously, it's that simple. So you've got your API gateway, which is accepting all the traffic, and then you can have different routes, like I was talking about, right? Going to different set of services. If you do not have the API gateway, you can obviously replace it with a load balancer. That's totally cool too. In fact, you can also, have your own custom implementation here if you like, right? I'm not sure why you would do that, but yeah, it's possible. So then all of these are different, implementations of your service, microservice. Each of them is essentially, dumping logs, perhaps. You remember the correlation key concept? So if your business user says that, look, my user is coming in, I really don't know where the drop is. I really don't know where the failure occurred, at what layer the issue occurred. How do I backtrack that? Obviously, developers love logs. That's one way, that's the only way, right, where you can figure out what went wrong. So you could potentially have all of these services depositing logs in a central repository, CloudWatch perhaps. You can have periodic exports from CloudWatch going into S3, and then you can use Athena to run queries on it. All of these services we have done. Or you could take those logs and put it in Elasticsearch, and you can build your good old classical ELK model, right, to do your analysis. Not just your forensic analysis, but also real-time server logs, right? You could build all of those services, or rather, those business processes to find out where the
Mohan, I told you not under the table,
exactly
Nana, come out of there.
Improved on things.
Every time.
And obviously, when you're talking about on-prem,
you
can have a connectivity from on-prem to the cloud, and by a
you can't sit under the table,
VPN or Direct Connect or whatever it is, and then you can have a global view of cloud and on-prem as well. So if you really see, are these the building blocks of microservices? Yes. Are they using the same set of tools that we've been doing? Yes, absolutely. Microservices auditing, a very interesting topic, a very important topic, right? Where you've got different layers here, and by the way, this picture is not mine, this is from AWS, right? You've got your static content coming out of let's say CloudFront. Then you've got the API gateway, and like I said, the combination of API gateway and Lambda could easily be replaced with a load balancer and a bunch of EC2 instances in an auto-scaling group, right? So there can be multiple implementations at this level. So then you can have your data store and all of that. AWS config is essentially what I was suggesting, which keeps track of the configuration of your instance, right? And then you can collect all the metrics from this entire infrastructure, right? And you can have notifications. So the point which I just now talked about, right, that do you have enough checks and balances in place for you to get notifications when some things are changing? Can you implement all of that? Yes. Now help me understand this. Can I scratch this word microservice and I replace that with application auditing? Do you think that this diagram will still be applicable? Absolutely. What's changing? Nothing is going to change. Probably instead of API gateway and Lambda, you might use EC2 instances where your monolithic application is deployed, but nothing else is going to change. Maybe this DynamoDB will be replaced with an RDBMS. Apart from that, there is no change whatsoever. And that's my final point with respect to, convincing you that we have been talking about the services, right? And those set of services can easily be applied. And I hope you are now convinced, having seen some of these examples, right, in the world of microservices as well. So microservices from a quote unquote implementation perspective is no different than what we have been doing right until now in your BGPCC journey. And these are the standard set of services. By the way, as I already mentioned, this picture is not mine. This is from AWS. And finally, the last slide that I have, right before I throw the floor open for general discussions and any other questions you may have, right? We talk about the 12-factor app now, don't we? Let's take a look at that. First is code base. Well, code commit. It can be a Git repository. Dependencies, depending on the programming language, you figure out the dependencies in your code. Or alternatively, those dependencies could be other services. Either way, right, it's got nothing to do with the cloud, honestly. Config, you can have central config servers. You can have your configuration stored in environment variables.
I'm in a class.
You can have a metadata URL that can deliver the configuration to the EC2 instances. I'm taking AWS as an example here. Same thing, by the way, 169.254, 169.254 works in GCP as well, Google Cloud Platform. Backing services, right? You can have your other set of services, which could be a private load balancer. It could also be, say, a database. It could also be a NoSQL. It could be any other service that you are interacting with. You can have a configuration file. You can throw those configuration in there. That's how you can do it. Build, release, run. I mean, all of us have seen this long enough. I really don't have to talk about that. But if I were to take a cloud example, right, I can potentially say that I can use code commit, code build, code deploy, and code pipeline. So the moment I do a git push, the pipeline kicks in and it refreshes dev.
Motion detected.
Then I can have an approval process. Then I can push the code in a different branch that refreshes stage. And once I have an approval there, I can push the code in another branch, which refreshes prod. Refreshing prod can happen in many different ways, or the environment can be maintained in many different ways. You could be refreshing a Lambda function. You could be refreshing a Docker image. You could be refreshing an Amazon machine image. Either way, that strategy is left up to you. And by the way, doing all of these three things, right, means you are doing microservices, or it may not mean you are doing microservices. Depends on the amount of, or what is the project that you're working on. If it's a monolithic application, all of these things still apply. So to be honest, this 12-factor application, or rather 12-factor app, is usually associated with microservices, but I honestly believe that they still equally apply to any project whatsoever. Processes, treat everything as a process. Fair enough, right? Containerization, if you do, right, you can have your applications hosted as a bunch of containers, and container is a process. Well, that's a literal meaning. Port binding, I don't think I need to talk about that. Concurrency, same thing. Disposability. Highly disposable infrastructure is something that I've been saying right from day one, right from course 1, week 1, when we talked about EC2 instances, infra as a service. Remember, I said that as long as we have stateless machines, we can have a situation where an instance can go down and we can just shrug our shoulders and move on. Yeah, that's okay. Like in another instance will take its place. No big deal. Disposable infrastructure. Containers. We've always maintained the fact, the industry has maintained this particular position where containers should be treated as highly ephemeral. If a container is lost, so be it. However, you can also use containers for hosting databases, for which you need to do volume mapping, etc., just to make sure you retain your data. Anyway, disposability is definitely the call of the day, which gives us the flexibility and the peace of mind that, hey, if something does go wrong, the damage is minimal to none. Dev prod parity, I think we all know. Hey, you know what? Everything looked good until stage. I don't know what happened. The moment I threw this code in prod, everything just fell apart. Why? Because the situation or the environment of prod is different. So I think this is just a best practice. It's more of a discipline rather than anything else. Logs. The more said, the less it is. We love logs. Admin processes, yeah, that's fine. So if you really look at it, these are the principles in some shape or form we have been talking about right from the beginning. So my point is, and this is where I really don't have any more slides, is when we are looking at microservices, you can have the same set of tools to deliver a microservice. Using the same set of tools, you can deploy monolithic applications. Using the same set of tools, you can deploy a lift and shift kind of a project implementation as well. In fact, just very recently I was having a discussion in a completely different context. I would like to coin a new term here. It's called private software as a service, private SaaS. So some of these organizations, what they're trying to do is they are looking at offering quote unquote managed services. And the point here is, or rather the example here is Teradata Vantage. I think there is a application from Teradata. Some of you might be familiar with it. I'm not, by the way, but I knew purely from a cloud perspective. What's the value proposition? This is a customer who has Teradata on-prem. They're looking to go to the cloud. And they're essentially saying that, look, historically, we have been managing this entire Teradata infrastructure on-prem, but on the cloud, we won't. Teradata, can you help us to do this? So Teradata says, sure, I can. And what I'm going to do is, I'm going to have a VPC in their own account. And they're going to have this entire implementation, obviously, with all the best practices that they know. So no one better than them implementing their own application, own product. I'm going to have and then the customer can VPC peer from and establish that connectivity. So the customer applications are on VPC 1, peering with VPC 2, and VPC 2 is owned by the product vendor. Private software as a service. So this is a dedicated infrastructure which Teradata is offering to these customers. So that's also another approach. What it's got to do with microservice? Well, if you really look at it, can we not now treat the entire Teradata implementation as a gigantic big black box, it could be a backing service. Point number 4 here. So a backing service is nothing but something that I can configure and I can integrate with without us having to worry about it. So what is the whole microservices principle? Individual atomic teams which are completely autonomous, creating, maintaining, managing services. Why can't it be a third party? And they are going to have this entire implementation. So using the same VPC peering concept that we talked about, course 1, week 3, we could extend that and create a backing service powered by a third party. How awesome is that? Which are completely autonomous. So all of a sudden now the enterprise is super kicked. Now they are saving costs. Why can't it be a third party? Right? And no overhead of maintaining this monstrous application component. So this is a recent use case that I came across. I was saying, that's pretty good. Right? So if you're a product maker and you've been, predominantly on-prem, selling your application, shrink-wrapped CDs, etc. Well, of course, nobody uses CDs these days, but whatever it is, you get the idea, right? You could potentially now get into this private software as a service, although it's not really an industry term, but in my mind, that made sense. Software as a service because I don't have to manage anything. Everything gets taken care of and it's dedicated for me. So it's private. So private software as a service. You could potentially consider that as a business model. And this is particularly applicable for customers who are looking at getting a completely secure implementation for themselves. What is that? It's nothing but a backing service. This is a rather monstrous implementation of a backing service, and backing service is one of the 12-factor app. So it's pretty interesting, right? So I honestly think, when we are looking at microservices, the whole idea of implementation or the focus on implementation, right, becomes your point number 2. It's not point number 1. Point number 1 is about, why should I do this? And the questions that Manji has been asking, is my expenditure justified? If I don't do this, is it going to question my survival in the future? I think those are probably the more important things we need to worry about. Implementation, you guys have been doing for 3 months. Implementation is not a big deal. All right. So yeah, I just wanted to, I prepared this particular material to try and convince you guys that this is not a hypothetical theoretical course, right? Because there is nothing in practice that I can show you that is different, that's going to be any different than what we have been doing for the last 3 months, 4 months, okay, in your journey. All right, folks, you know what? I want to take a short 4-minute recess, right? I'm going to come back in exactly 4 minutes from now, right? All right, folks, thank you very much for your patience. I am back, so we can resume. Okay, so honestly speaking, I really don't have any more, material to share with you. But let me, you know what, share this particular YouTube video link. And by the way, folks, in case